Good morning, everyone, and welcome to Google Cloud Platform Live here in San Francisco. But I also want to welcome every one of you who's watching from our offices in Seattle, New York, and London, and also from the many viewing parties, online viewing parties all around the world. So I'm Hölzle, and I'm responsible for the technical infrastructure at Google. My team, which includes thousands of engineers, builds and runs the infrastructure that all of Google and now the Google platform, cloud platform is built on. So the data centers, the networks, the servers, and the software systems on top of that. Now, I started in 1999 to work with Google, and it's really gratifying for me to see that this platform, this super efficient and scalable and fast worldwide platform, is now available for everyone to use to deploy applications to pretty much any device, any user, pretty much anywhere in the world. Now, the Google Cloud Platform is a central part of our infrastructure development. And we're investing heavily in it to make it as great a platform for external users as it has been for internal users at Google. So we're laying the groundwork for years and years of improvements and innovation. And while we already have a strong platform, these are the early days, so you can expect a lot more. There's many things that are still hard in a platform, but we see a clear path to making developers phenomenally more productive. And build applications that really take advantage of our platform and all the services that it has to use, be that storage, compute, or higher level things like maps or speech recognition or translation. And Google is really committed to the Google Cloud Platform. And as you'll see today, we'll be introducing new features at a pretty rapid pace. So today, I want to spend my time with you on three particular themes or topics. First, a quick look back at what we've done in the last 12 months or so. But then second, while we've already accomplished a lot, I want to talk about the challenges that people still face in the cloud. There's a lot of ways in which the promise of the cloud isn't fully met yet, and we see that as a major opportunity. So we want to make developers much more productive. And so in the third part, I'll talk about how we are going to do that. Today, we're announcing new functionality, new pricing that will help you developers be more productive, more economical, and hopefully have more fun while you do it. So first, let's look at a few highlights from last year. 12 months ago, it's actually hard to think back 12 months ago because our world was so much different back then, and we changed so much since then. So obviously at I/O last May, here in San Francisco, we introduced Compute Engine, so the ability to run VMs in Google data centers. And we introduced them with a few cool features, such as large persistent disks and per minute billing, so you only pay for the minutes that you actually use. We also introduced at the same time PHP for App Engine. PHP, obviously, one of the most popular languages, and PHP for App Engine having been one of the most popular features of all time, feature requests of all time. Then in August, we showed you Layer 3 load balancing, and you might remember in November when we demoed it that it can reach 1 million requests per second from a cold start in 5 seconds with no need to pre-provision or warm up anything. Right? So even a 1.0 product like load balancing is actually pretty mature and pretty stable. And the reason for that is that it's based on the same code base that powers load balancing for Google.com. You're going to see that a lot from our infrastructure. Then in December, we put Compute Engine into GA, general availability, and introduced a few more new features there that I'll talk about in a minute. On the data side, we also did a lot. We introduced Cloud Data Store, our fully managed NoSQL data store that scales to pretty much anything you can throw at it. Based on our very own Bigtable, the system that actually started the NoSQL revolution. We have offline disk import, encryption at rest, native connections for Cloud SQL. So one example where we're following open APIs so that you can use all the tools that come with the ecosystem that's been built up around these APIs. So something we're really committed to in the Google Cloud. Many improvements to persistent disks, and then SQL went GA general availability just last month with 99.95% SLA, larger instance types, and encryption of all data at rest. Well, we didn't stop there. We also introduced many improvements to BigQuery. So for example, now you can join huge tables with ease and really do big data computing at scale. We have dedicated memcache that, again, scales to pretty much arbitrary size and load. Lots of other updates. A mobile backend starter for iOS. So now on both Android and iOS, you can build the backend for your application with very little effort. And cloud endpoints let you do RESTful APIs for your own applications with little programming. And just last month, we announced HIPAA support, adding to the long list of certifications that our cloud already has. So that's great. And I want to spend a little bit more time on one feature, just one of these, and we couldn't really mention all of them, but one of them is live migration that we announced. So when Compute Engine went GA last December, it came with a unique feature called live migration. Now, why is that important? Well, as a cloud provider, you're faced with a dilemma, because you can either have an up-to-date infrastructure, patch your operating systems, upgrade, introduce new features, and so on at a rapid pace, or you can provide long-running VMs to your users. Right? But you can't really do both, because if you apply a security patch to the OS, the underlying host OS, and then have to reboot the machine, the VM can't really survive that. But live migration solves this dilemma and lets us provide both. And to show you how it works, I'd like to introduce Chris Elliott to give you a demo. Here you are, Chris, of live migration.
So in order to demonstrate how seamless live migration is for our customers, we built this sample application here, which is going to live stream an HD video from an instance that is undergoing live migration. This instance is physically moving around in our data centers while we're live streaming this video. And this happens blazingly fast, so I'm going to walk you through what you can expect to see here. This instance down here, VOD1, is the instance that will be streaming the video. And once we start live migration, you'll see a spinning wheel appear on that instance. Then it'll briefly flash yellow, and that is when the switch happens to the new physical host. So without further delay here, I have a terminal window into my instance, and I'm going to start a script that is keeping an eye out for a signal we send to the VM when we're running live migration. This script is then going to fire off to the App Engine app you saw earlier and update that UI. So we're good there. Let's jump back over to the UI. And I have an engineer waiting by in Seattle to simulate a physical hardware failure, such as a power supply overheating on this current hardware where it's hosted. And that will then trigger live migration. So let's get this started. And so we should see very shortly that this VOD1 instance will start live migrating once she runs the tool. And we'll wait for it to start live migrating until we start streaming the video. And here we go, 1080p video streaming while this instance is undergoing live migration. And so this is currently syncing the two states of those physical machines, getting ready to make that switch over to the new machine. And it should happen any second now, because it's amazing how quickly, there it is. And now we're on a new physical machine. That is live migration. That is how quickly we can migrate. Thanks. And there's 2 points I wanted to highlight here. One is it's amazing that it fundamentally changes how developers build on virtual machines. We have added intelligence to that layer, so we can now proactively live migrate you around hardware issues. So you're always going to have a high-performant, consistent system. Similarly, it allows us to upgrade under the covers so that you always have the safest and most secure environment to run your workloads on. And the other aspect here is this is completely transparent. That is the real magic. We built this demo on signals that are available, but you shouldn't even really care about this when you're running. During development and testing, we had a test cluster with customers running large production workloads, and they were trying to find any performance hiccups to find when live migration happened. We ended up getting an email at the end of the day asking, hey, are you not doing live migration? What's happening? When in reality, we moved them back and forth 10 times that day. It really is seamless, fast. The instance is exactly the same IP, same configuration, and you really don't need to know about it live migrating at all. And at the end of the day, the only thing that actually tells you it migrated is a little note in your operations log. That's it. And this is how we can, one of the ways we can provide high performance computing with Compute Engine and give developers the consistency they expect from Google. Thanks.
Thank you, Chris. So you can see, even though our VMs may look similar to other VMs, there's really a lot of innovation under the cover that make it a unique platform. Now, let's take a look at what kind of adoption we've been seeing. We now have over 4.75 active applications running in a Google Cloud Platform, continuing the strong trend that we've seen last year. And App Engine alone gets over 28 billion front-end requests per day, every day. So for comparison, that's more than 10 Wikipedias, worldwide Wikipedias, just for App Engine front-end. On the back end with Data Store, the numbers are even more staggering. Data Store currently serves 6.3 trillion requests per day. Now, trillion is really a very, very large number, so it's hard to put that in relation. One way to visualize it is as 30 operations per day, every day, for every person living on Earth, just in Data Store transactions. And finally, we've been working a lot on being not just the fastest cloud, but also the most cost-effective cloud. And it's great to see this starting to be recognized in the press. InfoWorld, for example, reported that we ran their benchmarks faster than any other cloud and less expensively than any other cloud. So who is on Google Cloud today? Now, our customers range from small startups to public companies to large consumer services, really all across the board. Some of them are running their entire business on the Google Cloud, and others are taking advantage of just certain parts of their workload that fit really well into our cloud. So Costco, for example, runs their entire websites in several countries on the cloud platforms. Citrix runs their developer platform. Netflix, Zulily, TiVo use our storage. Airbnb and Zillow use our Translate API. Philips is developing or is deploying their Hue light bulb using the Google Cloud. And we power Khan Academy, Optimizely, and millions of other websites. And Wix, for example, or Web Filings are two businesses that are entirely based on Google Cloud. So last month, we traveled to Ames, Iowa, to visit Web Filings, a company that you may not have heard of, but that in 3 years captured 60% of the Fortune 500 market for financial disclosures. And so let's have a look of how they do it using the Google Cloud Platform.
We hear all the time when we talk about Web Filings that people are surprised that we're based in Ames, Iowa. People do expect us to be in Silicon Valley because we're very much a Silicon Valley type of company. At Web Filings, we build applications that help companies build their financial reports.
Web Filing started summer of 2008. We had 8 engineers in one of the founders' basement. We launched our product early in 2010. We grew very rapidly. We have 2,000 corporate customers now. 60% of the Fortune 500 use our flagship product, Wdesk, all running on Google Cloud Platform.
Building on Google Cloud Platform allowed us to spend money on infrastructure as we needed it and not have to make a big upfront investment in data centers and servers. So as we were growing, we were able to invest in customer service. A couple of days ago, I just looked at the dashboard and it's like, we're serving a bunch more traffic and I didn't even know that that had happened. Cloud Platform scales on demand. I don't have to spend my time thinking about it. And it gave the companies a sense of confidence with Google running the data centers, that it would be a secure place to put pre-release financial data.
Cloud Platform offers us a variety of services. App Engine provides us with dynamically scalable application servers. Compute Engine allows us to run standard off-the-shelf services and components. We leverage cloud storage because that allows us to efficiently store and serve large binary blobs of data. BigQuery allows us to process and analyze large volumes of data in real time.
Being in a company that's growing this fast is really the experience of a lifetime, because we've been able to build on really cool platforms like the cloud platform, and seeing your product take off and be successful in the marketplace is an incredible experience.
All right, so web filings is just one of the many companies that I mentioned that really base their entire business on the Google Cloud. And obviously, they're all about enterprise. So let's look at another company that's all about the consumer. Now, we've all heard about Snapchat, right? A small team of engineers that have built one of the most popular applications on the internet today. And it's been fun for us to partner with them. And so I'm excited today to welcome Bob Murphy, CTO and co-founder of Snapchat, to the stage so we can hear their story firsthand. Sorry, Bobby. Please come up. Hello. Bobby. Great meeting you. All right, so I'm curious how you actually got started with both the idea and sort of the infrastructure. What led you there?
Yeah, so Evan and I got started on Snapchat summer of 2011. Basically kind of understood that visual content was the most engaging, interesting form of content that there was, and wanted to create a way to enable that to be a means of communication rather than a piece of content around which communication actually happens. So that was sort of the initial concept behind Snapchat. We launched on Google App Engine because I had used App Engine a couple times for some small projects, found it was super easy to get up and running. And when at the time, like obviously our biggest priority was to get a product in the hands of users in the world, in the real world, as quickly as possible. And so I turned again to App Engine, something I was very familiar with, and a platform that very easily abstracts away a lot of the complexities of building, deploying, and a web backend into the real world. And I think at the time, App Engine was actually still in preview, so we took a chance on a new platform. But I was fairly confident that given Google's kind of reputation as a very strong infrastructure company, that anything we built on App Engine would eventually scale if we needed to. So.
And it did. So
yeah.
Can you tell us a little bit about how the platform supported your launch of more recent features, like the Stories feature that you launched just recently?
Yeah, absolutely. It's actually been very surprising for us and super fortunate to see Cloud Platform kind of grow its feature set almost perfectly in sync with our own feature needs. It was actually funny looking at the timeline earlier because we've taken advantage of almost all of those product offerings almost immediately upon them being released to the general public. So around the time that we were launching Stories, which was fall of last year, App Engine was great for our core application, but we were looking for something a little bit more flexible to support the Stories architecture, which currently uses Redis on a huge cluster of Compute Engine instances. And so we were looking around, and that was exactly when Compute Engine launched to the general public. And so along with outgoing socket connections from App Engine front end. So it's actually perfect timing for us. That's worked and scaled tremendously well.
Mm-hmm. So you're running lots of Redis today?
We are. Yeah, we've got, I think, 256 master nodes and two slaves per each, and with a Twin proxy cluster in front and Google load balancers in front of that. So.
Okay. And so, obviously, that all came with a huge amount of growth, right? Not just in the beginning, but actually, It's really the amazing thing is that the growth has just been keeping up. So how have we helped you? I hope we have helped you.
Yeah, right? You guys have seen the growth firsthand. Absolutely. So, the biggest benefit is just the fact that we can focus much less on maintaining infrastructure and much more on building new infrastructure to support the features and the product developments that we need. In fact, actually, Tim, one of our VPs of engineering, just last week told me one of his biggest surprises at joining Snapchat was at not having to deal with the operational headache and complexity that he was expecting, and you would expect from a company at our growth rate and our current scale. So. Yeah, the biggest benefit is just the fact that we can focus less on maintaining infrastructure and much more on building new stuff.
And so, as far as I understand, you still don't have an operations team really, like an SRE team.
No,
not
not really. We're at about 25 engineers now, and a little bit of operational work here and there, but for the most part, everyone's focused on new feature development.
Cool. So if you had a piece of advice for anyone out there who wants to build the next Snapchat on a Google cloud platform, how should they go about it?
Yeah, I would just say it's a super easy platform to use. We got started on App Engine, which is amazingly simple to use and has scaled tremendously well. I've been absolutely impressed and very surprised that it's scaled as well as it has. Certainly thought early on that the kind of traditional notion of you build on a hosted solution and you reach a certain size at which you have to move off, I think is fading, and Google's kind of paving the way there. And so what's great about App Engine and cloud platform in general is that you get that kind of upfront ease of use with the added comfort of knowing that whatever you're building, if it needs to, will eventually scale ad infinitum. So
great. Let's
so.
Let's go to infinity and beyond. So
right.
thanks, Bobby.
Yeah.
Thank you very much. So people like you make it look easy. Just a small team building an insanely popular application and just scaling just like that. Now, even though there are success stories like this, as I mentioned a little bit earlier, building an app in the cloud is still harder than it should be, because you have to spend a lot of times worrying about things that you shouldn't really have to worry about. So too many things to think about, too many trade-offs to make, and too much work that's not really related to building your app. Let's look at a few of them. Consider pricing. Right? Pricing is still way too complex. It may seem cheap by comparison with your on-premise alternatives, but there's still a lot of room for it to go down. And moreover, it seems like you need a PhD to figure out the best options. Should you use on-demand instances that are flexible, or cheaper reserved instances? And should you prepay, and if so, how much? And for how long are you going to use them? And how much are you going to use them over the next year, et cetera? How do you optimize your cost versus your performance? Way too much complexity there. And often, developers also are forced to make design trade-offs, right? Like Bobby just mentioned, right? Should you get started really quickly, but then risk having to rewrite everything down the road? Or should you build something scalable, but be less productive? Now, we want cloud to be easier, and so we want to solve both of these problems. And today, in the next 10 minutes or so, I'll talk about that. So first, let's start with pricing. The chart here illustrates the typical VM in sort of the average industry cloud over the last 5 years or so. So prices have been falling by about 6 to 8% per year, which is pretty nice. But hardware prices during the same 5 years have been falling by about 20 to 30% a year. Right? So the cost of the underlying components, CPUs, RAM, flash, disk, has been falling much faster, because they've been following Moore's law, and cloud prices haven't. And so over time, that's opened quite a gap, right? Over several years, easily a factor of 2 between the two curves. And we don't think that this gap should really exist, because while the two curves can't be identical, because the VM price also includes not just the capital expenditures, but also the cost of running the VM, power, space, maintenance, administration, and so on. But the gap should be nowhere this large. Right? We think the two curves should be much closer together, and today we're taking a big step to bringing them much closer, and we think over the next 2 or 3 years that they will be even closer still. So I'll now describe how we do this. First, we'll have on-demand price reductions that make our on-demand pricing incredibly attractive. So Moore's law at work, basically. And then second, I'll show you how you get additional discounts that traditionally come with reserved instances, but with no upfront payment, no commitment, and no lock-in. And together, these two changes bring you industry-leading performance, price performance, really by far, without the complexity that's common in the industry. Good. Well, just wait for the details. So let's get started with the on-demand price reductions. So we start with immediate price reductions that bring our on-demand pricing to where it really should be, given Moore's law. On Compute Engine, we're reducing prices by 32% across the board and in all regions. So now our on-demand price is lower than the 3-year reserved price of most other providers. But that's not all. In storage, we price all storage now at a consistent 2.6 cents per gigabyte, no matter whether you use it for App Engine or for Compute Engine, and no matter whether you store a gigabyte or a petabyte. So for most users, that's a 68% decrease in storage cost. And our lower cost DRA alternative that gives you the same durability with a little bit less availability is 2 cents. So another more than 20% cheaper than that. But that's not all. On BigQuery, we're also reducing the on-demand prices by 85%. So now BigQuery is really accessible to everyone. And in BigQuery, we're going one step further because our largest customers have told us that they want predictable throughput for their applications. And so now you can analyze any amount of data with a chosen level of throughput in 5 gigabyte per second increments at a fixed price. So you can, you just tell us how much performance you want, right? What throughput you want, and we just provision everything for you, so you don't have to worry about what hardware resources you need to pick and how many of them and where, et cetera. So with other cloud providers or on-premise solutions, if you wanted 5 gigabytes per second of query throughput, so for gigabytes per second, not megabytes per second, you'd pay about $80,000 per month. And you'd have to worry about picking the right configuration and everything. So with Compute Engine and BigQuery, this is just $20,000 a month, so 75% reduction. And on top of the predictable performance, you also get on-demand elasticity so that when your needs really spike, you can go even higher. So together, we are really resetting the price curve in a cloud to where it should be. And this isn't a one-time step. This is a philosophy. The price trend of virtualized hardware should follow the price trend of real hardware. So it should follow Moore's law. And with the Google Cloud Platform, you're going to see exactly that. Now, one more problem with pricing is really that it's, as I mentioned, it's too complicated. So now we've lowered the prices. But the original dream of the cloud and the original promise was that you could get elastic capacity. So on-demand capacity. You only pay for what you use. You don't have to pre-provision, right? You don't have to commit. And it's cheaper than anything you could do yourself. Now, the industry hasn't really evolved towards that simple concept. In fact, along the way, things have gotten more complicated, like much more complicated. Here's a graph that shows the total cost of a typical VM over 3 years, given different pricing choices. And so you can see that there's a huge difference, a factor of 10 difference between the lowest and the highest price, depending on what price plan you choose. And it's the same resource, right? So for the same resource, you can pay 10 times more if you don't pay attention. So the question is, should you use on-demand instances, or should you prepay to get a reserved instance? And if so, how much do you prepay, and for how long do you want to reserve this instance? And you have to guess, how much am I going to actually use this VM for the next year or the next 3 years? Right? This is not simple on-demand elastic computing. Right? This requires a PhD in finance to kind of get right. And so either you have someone on your team who spends a lot of time worrying about it, or you're probably paying too much, or both. So this isn't completely crazy, right? Reserved instances actually have a purpose because they try to reward you for having a predictable, sustained workload. And of course, you should get a discount for having a sustained workload. But we think that you should get that discount with no upfront price, with no upfront expenditure, with no contract, no lock-in, and just no complexity. So how do we do that? I'll show you how. Today we're introducing sustained use discounts. We want you to be rewarded automatically for having sustained usage without you requiring to pre-plan. So we're moving the burden of planning from you to us. How does this work? Well, here's an example. We start with the low rates that we just announced, so rates that are lower than anywhere else. But once you use a VM for more than 25% of the month, your price starts dropping. So every additional minute becomes cheaper. So that means that if you have a 24/7 workload that you use for an entire month, like a database instance, then in effect, you get a 53% discount over today's prices. And what's even better, you don't, this discount applies to all instances of a certain type in a region. So even if you have a VM that you restart frequently, as long as that VM in aggregate is used more than 25% of the month, you get that discount. Right? So simple, easy pricing that gives you a discount based on your actual usage with no commitment up front. And remember that our pricing already has simplicity built in all kinds of other places. So you have per minute billing, where you only pay for the minutes that you actually use. And you have linear scaling of prices across VM types. So if you need a VM that has 4 times more CPU and 4 times more RAM than your current VM, you're going to pay a rate that is 4 times higher. Right? There's no penalty for using a larger machines. Things just scale as they should. So with these price principles, we've really taken the guesswork out of pricing. Your developers no longer have to double as finance planners. We do that for you. You automatically get discounts based on your actual sustained usage without any commitments. And that really was the original dream of the cloud that I talked about. You have on-demand capacity. You pay for just what you need, but you get a great price. That is a world that you can live in, right, as long as you use the Google Cloud, because that's the experience you'll have with us. So now let's turn to the other part that makes cloud computing harder than it could be. And mostly it's that you have to work around certain limitations that are in the cloud that cause you to do extra work. Let's look at a few of them. First, just the basic problem of time to market versus scalability, right? Should you build something that is quick and works, or should you make it scalable, right? There's too many examples of startups that had to go rewrite their backend just as they were getting really popular, the success failure, essentially. Second, flexibility versus automation, right? Do you want the flexibility and the openness of VMs, or do you want the automatic management of App Engine? And then third, big data scalability versus real-time analytics, right? Do you want to analyze really, really large data sets, or can you deal with the special demands of ingesting large amounts of data and analyzing them in real time? And now fundamentally, these are all hard problems, but we want to make the cloud easier. And so we believe that you should not have to choose between those apparent opposites. We'd like to turn this or into and we'd like for you to be able to do all of the above in the same infrastructure. And how we do that, to show you how we do that, I'd like to call up Greg DeMicheli. Sorry, Greg. So he can't pronounce my last name. I can't pronounce his last name. So I think we're about even. So Greg, come up, and Greg will explain to you how we do all of this. So Greg, all yours.
Thanks, Urs. Thanks, Urs. It's really no exaggeration to say that cloud is one of the biggest trends that's changing the way that developers operate. And with the new pricing that Urs announced, we really think that this will be opened up to even more developers to take advantage of the promise of the cloud. Now, before I deep dive into those hard trade-offs that Urs talked about, I want to spend just a minute and update you on a couple of very common requests I've heard from customers since we met at I/O. The first one's around operating systems. We know there's customers out there who want to run specific operating systems because they have workloads that depend upon those operating systems. So today we're announcing the GA availability of both SUSE and Red Hat Enterprise Linux on the Google Cloud Platform. So if you have workloads that require either of those products, with one click you can deploy virtual machines using those two operating systems. But of course, it's not just a Linux world. And one of the things we hear a lot is, hey, Google, are you really ever going to support Windows? And the answer to that's easy. Our customers tell us they want Windows, so of course we're supporting Windows. So starting today, we have preview support for the most popular version of Windows Server out there, available on the cloud platform. So if you're an enterprise and you have workloads that depend upon Windows, those are now open for business on the cloud platform. That's not the only common request that I've heard in the months since we were at I/O. Another one is around network management. We've heard from customers that having to manage their DNS infrastructure in one place and managing their virtual network configuration in another is a pain to keep those up to date and keep those in sync. So today we're announcing Google Cloud DNS, an authoritative DNS as a service, built, operated, managed by Google, Google scale, Google reliability, with a simple API and integrated into the Google console. So as a developer now, you can manage your network infrastructure for your applications and your DNS all in one place and get very high performance, easy to use DNS. So those are a few of the just common requests that we've had. Let me turn now to those hard trade-offs that Urs talked about. Now, the first one we want to dive into is around time to market versus scalability. So let's start at the beginning. You're a developer. Maybe you're at a startup. Maybe you're at an enterprise, and you're building an application. Right away, you know that you are going to be successful. So of course, you want to build for scalability so that when you go viral, your application supports it. But you've got a manager, whether that's your manager or your board of directors or your stakeholder. Somebody is telling you, get the application out and get it out yesterday. So at some point, you feel this pressure to maybe not spend as much time on scalability and really just go with whatever's the most productive thing to build. And then you pay the price. The app goes viral, suddenly your app is down, and now you're frantically trying to rewrite the back end while your customers are not getting served. We think that's a false trade-off. We think you should be able to take advantage of the Google scalability that we've built the cloud platform around from the beginning, but you should also have a very productive developer experience to do it. You shouldn't have to choose between developer productivity and scalability. So to do that, we've been focusing on a couple key areas. One is making sure that when you come to the cloud platform, you can continue to use the existing tools and services that you know and love. Whether that's Git for your source code repository, whether that's Maven and Jenkins for build and continuous integration, you should be able to continue to use those tools and services and have them integrate into the cloud platform really nicely. Second, when you do a deployment, you should have the confidence to know that the deployment is successful and that you didn't have a bad deployment that resulted in your app not working. And third, when problems come up in production, and they will come up in production, because they never come up in testing servers, right? It's only production. You should have the ability to easily spot those problems in production and with one click make fixes so that your app is back on track running like you want without having to do a bunch of context switching from the console into a bunch of other tools. So to give us a look at exactly these things, I want to bring up Brad Abrams. He leads the product management team for our developer experiences group. And he's going to give us a demo of 0 to 60 on the cloud platform showing these productivity features.
Awesome.
Brad?
Thanks, Greg.
Do you need that?
No, I don't need that. So in his copious spare time, Greg's been building out this Cloud Event 2014 application. But he ran into a little snag, and he asked me to use my programming prowess to help him out. So what we're looking at here is the Google Developer Console for Greg's application. But before we drill into the console, how many people are command line fans? How many people are more productive on the command line? Let's hear it. Okay.
Yep.
Great. Yes, me too. So we're going to start there. I'm going to show you our new G-Cloud command line tool. The reason I'm more productive on the command line is because of keyboard shortcuts like tab completion. So I can just say G-Cloud tab, tab, and that shows me the list of options that are available there. And then, if I can type, a tab again completes that. Oh yeah, and then what were the options for components? I can't remember. Oh right, list is the one I want. Tab finishes that out. So pretty cool, huh? Okay. Fine. Okay. So we have a set of components that are available. I can add and remove those, but I have what I think I need there. So we'll clear that, and I'll do another G-Cloud command, and we'll go ahead, Cloud Event 2014, we'll go ahead and bring down code that Greg's already started onto our local workspace so that we can start getting started with this. So let's take a look at what Greg's already got. I'm going to use my second favorite editor here to check out Greg's code. And there, Greg, I think I see your problem. You forgot to give it a title, so let's see if we can do that. So GCP live. Okay, just save that. Now we're going to use Git to commit that to our local repository. How many big Git fans are you? Use Git? Yes? Awesome. So I'll do a Git commit, and I'll say add a title or whatever.
Or a tidy.
And then I'm going to go ahead and do a Git push. So when I did the G-Cloud init, I initialized my local workspace with a remote repository that's hosted for us in the Google Cloud. And now I've gone and pushed that up. So if we switch over here to the console, you'll see when I refresh this that our new source code viewer in the console has that change that we looked at. There it is, GCP Live. And now if I switch over to releases, we see this is the Git URL that we offer as part of every Developer Console project. You get a free private Git repository that's accessible to all the members of your development team on this project.
Now that's really cool, and a lot of people do use Git, but a lot of people also use GitHub, whether it's for public open source projects or even for private repos. So is there support for that too?
Absolutely, Greg. At Google, we are big fans of GitHub. And so we've gone ahead and added a Connect to GitHub button. So all the features I'm going to show you work great if you're using a GitHub repository or one of ours. So regardless of which you use, as a post-commit action, you have your choice as to what happens. We can do a build, run a set of unit tests before we deploy that into production. In this case, we've set it to build with Maven, run unit tests, and then deploy to our cloud platform. To give you a peek inside a little bit about what's really happening, when we configured that build, what we did is we spin up a Compute Engine instance. And we installed on your behalf Jenkins, Maven, the JDK, everything we needed to do reliable builds. And then when that Git push happened, we pulled down all the code and did a clean build. And then when that build passed, we ran all your unit tests and then pushed it to production. So you can be more sure you get a safe, reliable deployment. And you can see as I've practiced this demo, the spikes in the build machine. So if we switch back over to cloud deployment, you can see our release history. And what you see here is that we added that title, we did a build, test, and we deployed that into production all in the time we've been talking here. So if we switch over and see Greg's app, Greg, it looks like a little meme application. That's kind of cool. And it's going to refresh with, and we see these, here are the memes you have. Yes, that's cute, petabytes of data. But let's, and there's the title that we added. That's great. I'm interested in what our top memes are here at the cloud event. So let's check those out. Oh, Greg, you have a server error here, a 500 server error. That's not good. These kind of issues are hard enough to debug when it's on your local machine, but when you have an issue like this in production, it's even harder. So to give you a sense about debugging this in production, I'm going to switch over and give some simulated load. So just going to throw a lot of traffic at that site. I saw some of you copying down the URL, so you might be throwing some traffic at it as well. So we'll go over and look at how we debug that issue. So I'm going to bring up the new unified logs viewer, and we're getting a log entry for every request that comes in. And you saw I just threw a bunch of requests at this thing. And we're aggregating all those logs across every front-end instance that we're spinning up into a single unified view. And so now I can just scroll through here, and notice as I'm scrolling, it's loading new logs. So it's easy for me to kind of find the logs that I'm interested in. I can also filter these, in this particular case, though, I want to look for a status 500, because that's what we saw, the 500 server error. I can also come in and filter by date and time. So if I get a bug report at a certain time, I can narrow that down pretty easily. These filters can be chained together with and or, so you can get exactly what you want. Okay, so here are the errors that we're hitting. And I can see, Greg, the problem here is this in this ominously named method, get memes buggy. That must be a problem.
I had to make it easy for you to find, Brad.
Yes, I appreciate that. So speaking of finding that, you'll notice the next thing we want to do as a developer is jump into the source, because that's where we're going to be able to fix this problem. But I have all this context loaded in my head. I need to get to the source quick so I can start bringing that to bear. So what I'm going to do is notice that right here, this is actually a hyperlink. So if I click right on this hyperlink, it brings me into the console, into our source code view with exactly the version of the source code that was deployed into production and that line of code highlighted. Pretty useful? So at this point, we could drop back to the Git command line. We could pull that file down and start operating on it. I can click on this Open an IDE button and use a variety of third-party or Google-provided IDEs. Or, because this is a very quick change, I can just click on Edit. Make this change right in the browser and go ahead and do a commit. And we'll just say fixed Greg's buggy code, and we'll deploy that into production. Now, how many of you have been debugging a production issue and you ended up SSHing into a production machine and twiddling some config file or messing with some PHP code? Who's done that? Yes, who's done that this morning? Okay, a couple of you. Okay, and that's maybe not the best idea, and that is not what we're doing here. We're actually committing this change back to the production Git repository. That change is attributed to me. It's repeatable. All future deployments will have that code as well. And we're running that full release pipeline. We're building the code on a clean machine. We're running all our unit tests, and we're deploying it only if all those things pass. Now, that takes a minute or so for those things to happen. So let's see if we can view that deployment in progress. So let's open that in a new tab. And we should see our new release. There it is. We fixed Greg's buggy code. Notice it's already built and tested that in just this short time, and we've deployed that out into production. So if we switch over now and refresh this, we should see the top cloud memes. And of course, they're all Jeff Dean memes. Guess that's how it goes. So what you've seen today is it's very easy to use tools you already know and love, like Maven, Jenkins, and Gradle to be able to target our platform. You've seen how easy it is to get reliable and quick deployments with our new continuous integration system. And finally, you saw how easy it was to find and debug an issue in production and get that fixed quickly. Thanks, Greg.
Thanks, Brad. That's really cool. I think that'll help a lot of developers make the jump to the cloud knowing that they can keep using the tools that they're comfortable with. So let's turn to the second of the big trade-offs, and it's a big one. You know, back in 2008, we introduced App Engine, which really became the first widely used platform as a service, allowing developers to focus only on the code that make their application unique and let us at Google handle all of the stuff like scaling and management and configuration, and let us carry a pager so you don't have to. But today, you face a tough choice. Do I use products like Compute Engine, infrastructure as a service, that give me total flexibility on open source packages I use and operating systems and programming languages, but at the cost of me having to carry my own pager, scale my own infrastructure, build out my own management? Or do I use products like App Engine, which free me from all that, but impose certain restrictions on me, like they only let me use certain languages or certain environments? This is another case of what we think is a false dichotomy, and it's one that we want to address. We think you should have access to the languages and runtimes you want and still get the auto management, auto capabilities of products like App Engine. So today we're introducing managed virtual machines. And managed VMs are just what it says. They are virtual machines that run on Compute Engine, but they are managed on your behalf with all of the goodness of App Engine. So this gives you a new way to think about building services, combining the freedom and control of App Engine, of Compute Engine, with the capabilities of App Engine. So you can start with an App Engine application, and if you ever hit a point where there's a language you want to use or an open source package you want to use that we don't support, with just a few configuration line changes, you can take part of that application and replace it with an equivalent virtual machine. And now you have control. You can do whatever you want without giving up all the benefits to begin that you chose App Engine for to begin with. So to see this in action, I've asked Chris Ramsdale to come up. Chris is going to give us a demo of managed virtual machines. He's going to take an application like Brad used, but he's going to add in now C++ code and some open source packages while still keeping the capabilities that he thought App Engine was great for to begin with. So Chris, why don't you show us managed virtual machines?
Cool. Thanks, Greg. Appreciate it. So what I want to show today is how we use managed VMs to take and add real-time image collaboration in the cloud and add that to Brad's demo. All right? So what we're going to do is we're going to have clients that are running inside of Chrome that are communicating back with a fleet of managed VMs via WebSockets for low latency communications. Right? And on those managed VMs, we're going to rely on ImageMagick, a third-party open source library that's an optimized C library for doing image processing and image rendering. Then we're going to use local disk to cache the renderings to make it super snappy. And then we're going to use App Engine's Java runtime as a serving stack to get data flowing from the front ends to the back ends. Now, as Greg alluded to, that kind of technology is not typically supported on platforms as a service, and not what App Engine is today. But with managed VMs, this is totally possible. Furthermore, we make it very easy to get up and started with this. So let me show you. Here, we're going to pop over to my terminal here. And what we see is a typical App Engine configuration file with a few parameters. So we have an application, we have a version, we have what module is running. And with a few more lines of configuration, we're actually going to turn this into a managed VM. So let me walk through these settings here. So the first thing is we're setting VM true. That's telling the system I want to run this on a managed VM so I have access to native resources and the ability to run native code. Furthermore, we get into a new section called VM settings. Here we specify machine type, for example. And since we're doing image rendering and image processing, we're going to crank up the horsepower on these VMs and deploy 8-core machines.
Now this could be any of the Compute Engine virtual machine types, 1, 2, 4, 8 or more cores, high mem, high CPU standard, whatever's available in GCE, you can use with App Engine as well.
Absolutely, Greg. And furthermore, as we innovate here, those innovations will flow back through this configuration as well. The next line is the settings for deploying the third-party code that I want on those managed VMs. In this case, we're using ImageMagick and just doing apt-get install to those managed VMs.
And again, anything installable via apt-get, I can specify here, and it becomes available to me in a managed VM.
Absolutely. This is how we're opening up App Engine so you can use third-party libraries like that and get them onto those VMs, those managed VMs, in a super simple way. The next line is we're opening up a port. In this case, it's an arbitrary port, 65080, and that's how we're going to do the WebSocket communication from the clients that are running in Chrome back to those fleet of managed VMs. And then for the sake of this demo, we're going to specify 2 instances because that's more than enough for this demo, especially since we're running 8-core machines. So we're going to escape from this, save it. And now since this is since we're running on the Java runtime and it's a Java application, we can use Maven to deploy this. Okay, so while that's running, I'm going to talk about what's happening under the hood. So if we can cut back to the slides, please. All right, the first thing that's happening is that we're relying on our G-Cloud tools to parse and to validate the configuration file that I just showed you. Assuming that's valid, which it is, it's going to communicate to our deployment endpoints and say, okay, I want to deploy this application. Those deployment endpoints are going to store some metadata about the application, the version, the template, the number of instances that are running. And then from there, we're going to go off and we're going to create the actual containers. In this case, we're creating 8-core Compute Engine VMs, and we're installing our Debian OS on top of that. After that, we're going to carve out the managed services and make sure that everything's lined up correctly for you. So in this case, we're going to do monitoring and health checking, task queues, memcache, and data store. We're also going to create secure namespaces so that everything is secure within those multi-tenant systems. And we're going to set up smart defaults, so it's very easy to access the APIs and get data flowing back and forth. From there, it's onto the serving stack. And since we're running on a Java runtime, we're going to install a web server, an application server, and a JVM. And then it's on to the interesting parts, the parts that you provide. So in this case, the third-party code that we specified, so ImageMagick on those managed VMs, and then most importantly, your code. We're going to bring all that up, we're going to do some health checking, make sure everything's running correctly, and assuming it is, we're going to install a load balancer, and then we're going to wire everything up for you. And the final step is we're going to take all of that and make sure it's co-located with the other pieces of compute that you're running. So in this case, Brad had showed you some front ends that we're running. We're going to take your managed VMs and co-locate those with your front ends so you get low latency and improved overall performance. All right, so if we can jump back to the demo. All right, so our build has succeeded. Let's go check that out in Chrome. So we'll pull this up. We'll navigate to the URL that's provisioned for us. All right, and there we see our new front end, Cloud Collabo, collaboration in the cloud. This is pretty straightforward. We're going to be able to upload an image. We're going to do some edits to that image. Those edits are going to be shared with the people that are collaborating, and then we can do some real-time conversation back and forth. So let's pick an image. All right, meme 2 looks good. All right, man of the hour, Urs. We're going to use his meme to actually get going. So that's uploading to cloud storage right now. All right, there it is. So it's uploaded. We see that I am the only collaborator, so let's change that. I'm going to share this with Greg. Now, demo note where I'm going to use Chrome profiles to simulate Greg and myself communicating back and forth. So we're going to bump over to Greg's profile. Oh, yes, looks just like you, Greg. Oh, you're a Despicable Me fan as well. I love it. It's great. That is like the craziest theme I've ever seen in my life. All right, back to business. OK, so I'm sharing this with Greg right now. It's going out. It's going to log him in. Wait for it. OK, there he is. All right. And you see now that Greg and I are collaborating on this image. Now, to show you happening in real time, I'm going to try to move this over here. OK, so I'm going to pretend that Greg is actually doing the editing, and you're going to see things happening if everything works correctly in my browser as well. So we'll dress it up with a frame first. Nothing goes with green like magenta. Grab that. Say add border. All right, good. We've got a border. Now we're going to add some high-end doodling. Now somebody had mentioned that doodling on Urs's image is probably a career-limiting move. But I said, hey, why not?
Only if the demo doesn't work.
Exactly. All right, so we're going to give Urs a big smile. Good prices in cloud. His famous earring, a little more bling. Oh, there we go. And now we see that it's happening in real time back to my browser. And so again, what's happening is that these two clients are connecting over WebSockets back to the managed VMs. We're doing the rendering, we're caching in local disk, and then we're sending the updates back to the Chrome clients. Now I want to take a second and say to all the App Engine developers and users that are in the crowd that like this typically wasn't and was not supported on App Engine, but yet it's been a top feature request consistently year over year. So I'm happy to announce that those feature requests are now fixed and available to you. OK, so it's not just about, thank you, all the App Engine developers in the crowd. So while the ability to access native resources and run native code on these managed VMs is fantastic, it's not just about that. It's about great developer experiences and great developer integration. So to show you that, I'm going to bump back out to the developer's console here. So here. OK, it's the same UI that Brad had shown previously. It's our developer's console. And I'm going to show how we've integrated App Engine and Compute Engine by drilling down into the App Engine tab. OK, we see our dashboard. We see our modules. I'm going to select our backend module. That's the one that's handling all the real-time collaboration and communication. We'll drill into the instances. And here we'll see the instances that are running from my application. So remember back in the configuration file, we specified that we want 2 managed VMs. Here we see those. And if we drill into this VM over here, give it a second. OK, and so there's the dashboard for the underlying VM. And if we move down on the page, we can see that it is, in fact, an 8-core machine. We've automatically configured an external IP for it. And there's some metadata here that allows us to manage the VM, quite a bit of it, actually. So that's drilling down into the VM. Now let's bubble back up and see how we've integrated all the managed services. If we come back to the App Engine tab, we'll go to our unified logs viewer. Now what's nice about this is it's not just unifying the logs on all my managed VMs, it's actually unifying the logs across all the compute that I'm doing, be it a front end running on App Engine or managed VMs that are running on top of Compute Engine VMs. So here we see that there's a fair number of servlets that are being hit for my backend. Got one for serving an image, one for creating the WebSockets connection. And while you could do all of this on an unmanaged VM, you could do it on a raw Compute Engine VM. You could deploy syslog or rsyslog. We think there's a more productive way. We think that by offering a managed and centralized service like this, you can become a more productive developer. And furthermore, if you apply that philosophy out to things like authentication, deployment management, configuration management, developer tools, developer console, that you can be a more productive and happier developer for the cloud. Now let's take a look at how, speaking of developer productivity, let's take a look at what we do with the underlying VMs. Now, we had mentioned that these VMs are locked down by default. So they're not, you don't have root access, you don't have SSH access into them. And that's for good reason. We don't want people going out into production making changes to one of those VMs that are running inside of a large fleet. It makes it hard to manage in a high availability manner. But we recognize the fact that there are times when you need to get to those VMs to do things like do some kind of debugging or check on a configuration file that you have or make some configuration change just to see what happens to the underlying VM. We make that super simple as well. So if we come back here to the terminal, we're going to do a gcloud instances, gcloud compute, instances list. Okay, and there's our two VMs that are actually running. And now we're going to enable debugging for one of those. So we're going to do gcloud debug, compute, debug. Use the local directory, which has the configuration for these managed VMs. And what that's going to do is it's going to go through that deployment endpoint and put those two managed VMs into debug mode, which is what you're seeing here. I'll clear that up. And if we do gcloud compute instances list again, so I can grab the name. Let's grab the first one. We'll SSH into that. Let's grab that guy. Instead of list, we'll do SSH. Okay. And now that'll SSH us into the underlying VM, which you see here, Cramsdale at AE-backend 1-0. Clear that up. Now, once we're on this VM, you have access to common tools that you would normally use on a virtual machine. In this case, we can do things like run netstat. Right? And we see all the activity that's running through the various connections on the VM. In this case, we can actually see up there at 65080 with the port we're listening on for the WebSockets communication. And then we can do things like interact with the Debian package man and see that the package that we specified inside the configuration file is actually on the VM. So in this case, we'll do dpkg, and we'll do a grep for, let's say, magic. All right, and sure enough, there you see that, in the bottom there, you see that our package is actually installed on the VM. And so all we need to do is we exit, we'll seal that VM back up, and things are good to go. So what we've seen here is that with managed VMs, we can take advantage of the auto management that App Engine provides with the control and flexibility of underlying Compute Engine VMs. We can make it super simple to get started with easy configuration, easy deployments, integration back with managed services, as well as integration with our developer console and our developer tools, right? So that you don't have to make a choice between, oh, I want platform as a service and auto management, or I want to choose flexibility with Compute Engine. Managed VMs brings both of those together, giving you the best of both worlds. And so with that, I'm going to turn it back over to Greg.
Thanks, Chris. So there you really saw the ability to blend auto management and flexibility in one offering. We think that's going to be a great way for developers to be more productive. So the last hard problem we want to talk about today is a big one. It's all about data. Big data is really revolutionizing the way people deal with analytics. And companies are able to get insights from data that was never before possible. It was previously just sort of a mass of data they couldn't make sense of. But if you take a look at most big data deployments, there's a lot of work in those that has nothing to do with analytics. It's about moving data from A to B, or sharding it so it's efficient, or transforming it from one format to another. None of which is actually about analyzing. It's all about setting up so you can analyze. What you really want to be able to do is take data as it's generated in its raw form, ingest it in real time as it's being generated, and start analyzing it the minute it's in your system without having to go through intermediate warehousing and transformation steps. And that's really why we first built BigQuery. BigQuery, you probably know, builds on a tool that we developed internally at Google. Early on at Google, we realized that we had to find a way to look at the log files of massive numbers of front-end web servers to see what's going on. And we knew that none of the existing data tools out there would be anywhere close enough. So we built an internal tool for that, and BigQuery is built on top of that. So it uses the same technology we use to do massive data analytics of front-end web servers, but with a very friendly SQL-like syntax. So back in September, we introduced in BigQuery a streaming API. And BigQuery streaming allowed you to take data as you're generating it, whether that's from applications or from physical devices, send it into BigQuery, and as soon as you send it to BigQuery, it shows up and is available for analysis. Well, we started out allowing you to ingest 1,000 rows per second into BigQuery. Today, we're taking that to the next level. We're announcing BigQuery streaming supporting 100,000 rows per second of ingestion. So what that means is you can take massive amounts of data that you generate, and as fast as you can generate them and send it to BigQuery, you can start analyzing it and drawing business conclusions from it without setting up data warehouses, without building sharding, without doing ETL, without doing copying. So to give you a demo of exactly that, of real-time large amounts of data being analyzed in BigQuery, I have a special guest we want to bring up. I want to bring up Eric Schmidt. Not the chairman of the board of directors, Eric Schmidt. The Eric Schmidt from the Cloud Platform team. Eric?
Thanks, Greg. I'm a solutions architect in the cloud platform team, not the chairman of the board. So, in this demo, I want to demonstrate how you can leverage BigQuery to do near real-time interactive analysis over rapidly changing massive data sets. Now, as Greg just talked about, we now have the ability to ingest 100,000 rows per second per table into BigQuery. For this demo, I'm modeling some use cases from a company called Glen Canyon. Glen Canyon is a pioneer in smart meter and intelligent network technology for electric power utilities. They have millions of meters in market today. This is an example of one of them. They communicate over Wi-Fi and 3G. For our demo, we're going to have these meters report out once a minute, 60 events an hour, and I'm going to virtualize these meters over the city of Seattle, which roughly has 400,000 meters in its network. At the end of the day, we're going to be processing around 17 billion events per month. You can flip over to the demo machine. All right. So the first thing I want to do is just dive into a couple very, very simple queries to give you some context about what's happening with the system. On my other machine over here, this is my meter system. I'm generating load to create hundreds of thousands of meter requests. This query here, I'm just going to do a quick count from my single table that I'm doing raw ingestion of records. I apologize to all my DBA friends out there for doing a select star with no where clause. So there you go. We have over 4.6 billion rows in this table. We're doing around a billion per day, so this is roughly a little over a week's worth of data. So what does this data look like? I'm going to go and look at my raw data table. I'll scroll down. Oh, first get details. Scroll down. And you can see down at the bottom, I have individual meter ID, the read time from the meter, its status. The status is very important. How many of you had to call the electric company to tell them that your power's off? Wouldn't it be great whenever you call them, they tell you? You have active energy. This is how much kilowatts per hour the home or business is drawing. And if I scroll all the way out, I have things like the actual temperature of the meter. So temperature increases of a meter typically indicates some type of mechanical failure. And finally, you have the insertion time, the time that the record was actually inserted into BigQuery. This record on a case-by-case basis is 128 bytes. So roughly, we're building around 2 terabytes per month just for the simulation of Seattle. But if you want to put this into perspective, you start multiplying the number of cities on the planet, you're talking about hundreds and hundreds of terabytes into petabytes. So what can we do with this data? I'm going to flip over. I'm going to re-render this. This is a real-time visualization of all the meters in Seattle, all 400,000. This visualization is powered by a standing query that I'm running that will calculate all of the average power for the entire grid. So you can kind of see this mean energy that's being drawn across the screen. It's a sliding window of approximately 10 minutes. So every second, I'm streaming on average around 8,000 to 10,000 records into the system because I have it completely distributed. And BigQuery is constantly ingesting and enabling me to query that data in real time. Now, let's go ahead and zoom in and try to find a location because it's kind of hard to see what's going on this map with so many points. So I'm going to find my local coffee shop on 19th, Fuel Coffee. If you're ever in Seattle, they have great coffee. I'm going to go ahead and re-render this map. And in the background, I have run another query that is doing geographic analysis just on the lat and long boundary for all the points that are in this view. So if I start clicking on them, I can go ahead and get some details specifically about just this meter. The interesting thing here to point out is I have one table, one single table for me to do my aggregations that I just showed you in the previous graph, or these graphs that are looking at specific atomic records, the active energy as well as the temperature. So I can go ahead and click around.
And this also shows, right, how BigQuery is not only for interactive analysis, but you can actually build applications that sit on top of BigQuery to do visualizations at the API level as well.
Exactly. So some of the queries that I'm about to show you that I was using in the console, those are running inside of a set of Python application as well as a Java application to power this visualization. All right, let's get back and look at some queries. This query is the average power by time. And I am going to go ahead and run this. This is fundamentally the same query that was powering the overall averaging of that entire system. Now, you'll note here up top where in my from statement, I'm using a relatively new feature inside of BigQuery called table decorators. What this enables you to do is basically filter down the rows that you would like to see that have been written into a particular table in a given time window. So fundamentally, I've taken 4 plus 4 billion rows and narrowed it down to roughly 800,000. This helps with query performance as well as reduce query cost. So you can kind of view table decorators as a simplified where with some benefits. So there you go. There's the average of the entire system right now, around 5.7 kilowatts an hour. This is interesting. I can do real-time, near real-time interactive analysis over lots of data, but let's write a bigger query, because after all, this is BigQuery. This query is the basis for the query that I was running whenever I was zooming in on my geo-coordinates. And one of the things I want to point out here, Boris talked about this morning, released a feature last fall called Join, or Big Join. In this case, what I'm doing is I am joining my raw meter table, those 4 billion rows, to a metadata table that contains all of my lat and long information for my meters. This is a great way to maintain normalization in your database. I'm a big NoSQL fan as well, but one of the challenges is you end up muddying your tables with lots of redundant data. Well, with the power of join, I can go ahead and just filter out, given lat and long, the meter IDs that I would like to address in my query. So I'm roughly filtering down to a couple hundred inside of that view. And I am averaging and also looking at their status to see if they're off and on. It's fundamentally the same query I was running before, except I'm using joins to filter out on lat and long. Now, I can average, so I have roughly, probably 200 to 300 in this view, and I'm averaging so I can see who is the highest user. I do a sort at the bottom of this query. I want to see who's the highest user of power on average. But the other thing I did in this query is leveraged cross joins and a statistical function called quantiles to look at the entire 400,000 meters that are in this system and look at the quantile distribution. I have 100 steps in this distribution so that I could compare an individual meter to the entire population. So I'm fundamentally taking 4 billion rows, narrowing it down to around 800, doing a join, and then doing a quantile back on the entire grid system. It's a big query. But you'll notice I only processed around 200 megabytes of data. I didn't process gigs of data. And I did this in roughly 15 seconds. So there you go. Meter number 163236. They are the highest average user in that geogrid. And ironically, they're also in the 99th quantile, because my data is all completely randomized, but it's randomized with the same patterns. Now, this same type of query, you might not even been able to run this if you were running in a NoSQL environment, or if you didn't have the processing power, you may have gone to lunch and then came back, right? So I have one more query to show you. While I've been running this demo on my machine over here, just making sure that our system is still up. Instead of running the system to report every 60 seconds or every minute, I've asked the system to report out roughly every 7 seconds. Functionally, I've taken 400,000 meters and turned them into 2.8 million meters. This equates to roughly around 45,000 rows per second being ingested into my table. I'm not doing any sharding. I have one table to do all of my analysis off of. Now, if you needed to do further RPS, you could shard, and you could use something like wildcards, and you could get hundreds of thousands or millions of rows per second into BigQuery. So there you have it. All of your data in one common environment. You have a friendly SQL-like syntax. You have high throughput, low latency ingestion to do near real-time interactive analysis at democratized pricing. So thanks for your time. I hope you enjoy the rest of the show. Please turn off your lights and go big data.
Thanks, Eric. It just blows my mind that while Eric was doing that demo, that we were putting in 45,000 new rows per second while he's doing the demo live. He gets like the gutsy onstage demo award for the day, I think. When you look at everything we're doing, this is a great time to be a developer. We're going to have drill down sessions on all of these technologies throughout the day, as well as product managers and engineers to help you answer your questions. So with that, I'm going to turn things back over to Urs to sort of wrap up, and thank you very much for your time.
Thank you, Greg.
Thanks, Urs.
All right. Well, as Greg said, this truly is an exciting time to be an engineer, because you can build an application for a global audience, and you have to do very little to do that other than focus on your problem. That is our goal. The amount of change and innovation around us that's happening right now is really incredible. And that creates a huge opportunity. And what we want to do is build the cloud platform that you want to use to take advantage of that opportunity. So really, a lot of what we focused on today was productivity. Right? How do we make you more productive in developing in the cloud, make it easier to build and test and deploy in the cloud using the tools that you already know. And then with managed VMs, you can have the flexibility of the auto management of App Engine with the flexibility of VMs. You don't have to choose between the two. And then as we just saw, BigQuery allows you to make big data analysis really just work at any scale. You don't have to choose between really high scale interactive querying, or real-time data, right? All of this, all these three things you get on one tool, one single tool on the Google Cloud platform. And on top of that, of course, we have made this all more affordable than it's ever been before by following Moore's Law. Because we believe that the price of virtualized hardware should follow the same trends that the price of real hardware follows. Really, Moore's Law is here to stay, and you will see that in our cloud. Now, on top of that, I have shown you how you can get additional discounts for sustained usage, but without upfront payments, without lock-in, without long-term commitments, and really without the planning hassle that you have to go into with other providers just to get a good price. So this is really a new way of thinking about pricing, I think. A way where we move the planning hassle from you to us so that you can focus on the things that you actually want to focus on. So everything we're doing with the platform really is about making you more productive and helping you, the developer, to do the things you love and let us do the rest. So we introduced a lot of things today, but it's just March. So you can look forward to a lot more later this year. And I'll certainly see many of you at Google I/O here in San Francisco in June, when we will have a lot more to say about the Google Cloud. But before we get there, we're going to go on a tour, a developer roadshow, starting 2 weeks from now, going through 27 cities worldwide. So look for that at cloud.google.com/roadshow, and I hope to see some of you there as well. So with that, enjoy the rest of the day, all the detailed sessions. Thank you for putting your applications in the Google Cloud. Thank you for attending Cloud Platform Live. Thanks.